there any questions out there? There are or not? Okay. I mean, no reason for me to start. But
Jess Elsher with White Cloud Security. We've had excellent discussion all week regarding IC systems, really in the install base. Are we also addressing the beginnings during detailed design, when the equipment comes out of the box? Are we protecting it when it's being configured? Are we protecting it while it's being integrated during testing?
good question. Please.
Hi, Gary Williams, Schneider Electric. It's a good question, and if you had asked me 18 months ago, I probably would have had to go away and check, but now I can say with confidence the answer is yes. Our company, along with a lot of others, are totally committed to ISA Secure, and part of the ISA Secure certification is the Embedded Device Security Assurance program. So we're now addressing security from concept right the way through to delivery. And we use third parties in order to qualify that we are in fact compliant.
I guess as an end user, I have to quote one of my vendors that's been saying it, is that, you know, only if we specify it. We do have to drive and encourage the suppliers to build it in, and they have to be rewarded for doing it. So we definitely have to ask for it and make sure that we're asking pretty loudly for it.
Please. Oh, I'm sorry. Sorry, Andy, I didn't see.
Oh, at the beginning, we talked about, you mentioned building armor around all of our systems to keep the bad guys out. Have we thought about, well, I'm sure you have a little bit, comment on putting guns in the underneath, and you don't necessarily have to kill them, but you can maybe find out who they are so that it will help law enforcement or whatever catch these people.
You mean like a paint gun? So one of the things to be very aware in cybersecurity is that there's laws as well as understandings between nations about that type of thing. Usually, like for instance, a commercial company, at least here in the US, is prevented from the idea of a hack back. However, they can configure their systems to where, you know, anything that's prudent. There was an incident, this is sizable time ago, but where the Pentagon had configured their routers to reflect an attack back, and you know it hit the papers as the U.S. hacks back hackers. It really was not that. It was merely prudent configuration of their systems. Yokogawa also gets into secure development of systems, but also as one of the three legs of secure system deployment, we talk about secure configuration guides, and also making sure that the overall systems and the kind of ecology of systems make sure that we live and work in a holistic system that secures front to back on those concerns. So one of the things that I really would urge everybody to start thinking about is, not just configuration of ICS, but also of the cosmology of IT systems out there. Make sure that you actually ask your IT people, what are your secure configuration guides, and if you don't have them, maybe it'd be good to start working on that.
I can never resist making a comment on anything, but we can't put the guns on the armored sheep. We can't even put cameras on the armored sheep. You have to be very careful of. And what I mean by that is that even on intrusion detection, we're counseled that we have to be careful about what we capture about who's in there. That in some countries that we're not even allowed to capture information about them.
I have to make a comment, Andy, just because it's appropriate to this. But during the break, you were here in the last session, I know, but I ran into a friend of mine from ExxonMobil getting a little biscuit there at the break. And I asked him if he was here, and he said he wasn't in this session, he was in another session we have, which is on smart devices. And he was telling me about, it happened to talk about a cybersecurity incident, the one where a security issue, the power plant in California that was attacked by snipers, for those that are familiar with it. And, you know, it caused problems eventually and went down, and there's discussion of how you could have sensed it. But actually, he was talking about, someone gave a presentation there, I don't know who it was, about something they got from the military that actually was guns to protect. But it wasn't guns, it was sensors that could detect a gun going off in a local location and then send a beam of energy, I don't know the technology, that actually would go to the person and burn them. And, you know, you could only take it for like 3 seconds. It raised your temperature to like 135 degrees. I mean, you're 98.6. So I guess there are ways. I don't know what we do with systems, but it was actually using sensors to, you know, I always make the analogy with the popcorn detectors. I'm always impressed with our microwave that it decides when to stop, you know, by counting how frequent, whatever their methodology is. But I guess there are ways. But anyhow, I had to say that. I'm sorry. I just thought that was cute. Yes, please.
Keith Campbell, getting to this issue of funding and ROI, you know, those of us that were involved in Y2K, we see a huge number of parallels here, but yet it seems nobody wants to talk about them. And both with foresight and hindsight, we saw a lot of issues in the decision-making process that were obviously flawed. So is anyone studying what happened there, studying the psychology, the groupthink of what led to the mistakes in Y2K to try to get those issues out of the way of solving this problem?
Is someone there?
I don't know. The only comment.
Bill Cotter. He's
Yeah,
gonna
I
comment
can't
on that.
resist, right? You sat here, so you suffered through it. The only thing that flashed into my mind when you were saying that is that, you know, of course, all the bad things get lots of publicity, and so one of the things we miss is, you know, there's a lot of good that goes on, and we forget that. We always talk about all the negative and that kind of thing. So there's a lot of good decisions that go on, and we're not analyzing that either as to, you know, what works. And a lot of times we're missing it.
I know. I guess I have a chance to ask a question here. I was standing there while I wanted to ask a question to James after his presentation. Because I model too, my background's in dynamics and modeling and things like that. And I love the modeling tools, but the problem all the time is how do you build the real model for those behaviors of the blocks you had, for example? I mean, how do you know what impact doing something is going to have on vulnerability? I'm just curious how you did it. It's a rather technical question, but.
No, that's a really good question. So there's a couple of things that we can do to build confidence in our models. First, the easiest thing that we have at our disposal is the fact that we're looking at aggregates of individuals. And when you're looking at aggregates, you don't necessarily have to know the individual decision-making process of the individual components of those aggregates, because when you average out little pieces, you get something that's slightly more tractable. So that's really helpful. The second thing that's actually becoming really exciting to us is that with the sort of big data revolution as we're seeing it, we're getting a lot more information about social systems, about systems of human actors. So we've always had lots of abilities to measure technical systems, but now we're actually getting some insight onto those as well. And so there's a lot of emphasis on using those new data streams and new data sources that are available to help us validate our models in a more quantitative way.
Okay. Question there. Oh, I'm sorry, there's Ed. Go ahead.
I can't resist talking about Y2K, living through it, and you're spot on. The thing and the corollary and the parallels are nobody really took a look at impact to the equipment in our mission in Y2K. They just went out and inventoried everything, and without the thought of could it even affect it. And you know, PLCs and DCS controllers, they get to the bottom of the processing of the logic, they go back to the top, they do it again. They don't care what date it was and what time it was. You might get some reports that had the wrong dates and times on it. You might get some custody transfer things. And I think the parallel here is we have to truly understand our mission before we go in and try and protect against everything. Yeah, this is where we have to fine-tune what we're trying to do. Strengthen what we know needs to be strengthened, and don't just trying to lock down everything against all possible attacks.
That's kind of what Key was talking about, I think, her model, in a sense. I mean, that was what she was addressing.
Sorry. I had this conversation with Ed during the break, and I think perhaps the way I explained the method, I went too fast at the beginning, but this whole analysis modeling approach is a top-down approach. So the very first step we do is to identify the mission. What is the thing that you want to avoid? All the subsequent steps that when you identify some kind of failure, vulnerability, only if it affects that top-level goal you want to protect, would it be on the list? If it's something else that doesn't tie into your top goal, this method would say, you know, just skip it. So it is a top-down filtering process, and the method is capable of doing that. Just want to share with everyone. Thank you, Ed.
Hi, Don Bartusiak from ExxonMobil. So, question for James: do you think you've properly represented like the state-sponsored agents in the model who might not be influenceable by economic factors?
Right. The model that I showed you today does not have any of those state-sponsored components. And there are a lot of interesting dynamics that do go on in the state arena. One of them is around the idea of legitimization, the idea that a public state-sponsored attack, if acknowledged, in some ways says that this is appropriate behavior for states to be conducting. And that legitimizes this behavior not just for other states, and you get that sort of arms race type behavior that we've seen in so many other cases, but because there are civilian actors with the capability of acting in some ways like states and having similar capabilities to what those actors can do, we legitimize it for those types of actors as well. And the danger comes when the converse happens, because it's so often difficult to, as we saw in the Sony case, attribute a specific incident to a state actor when it could just as easily have been, well, maybe not just as easily, but possibly been done by just a couple of guys. We're getting into areas where actions behind individuals could kick off sort of legitimization dynamics for state actors. And that's really interesting and really underexplored.
I'll mention quickly that we do have this as a line of research that we are continually work on, and I will also acknowledge that ExxonMobil is a member of the IC initiative, and we thank you for that.
Okay, over there.
Can I
Please.
follow up on that last conversation a little bit?
Oh, please, I'm sorry, Jeff.
Yeah, Jeff Melrose, Yokogawa. I think the state actor dynamic is very interesting, and also the Sony breach is very interesting because there was this whole flip-flop of it's an insider, disgruntled employee, it's a state actor. What I think most people don't consider is it quite possibly could be both. And one of the things to consider also with nation-state actors is the very idea of threats that go through human vectors. In other words, compromising of internal people, particularly trusted internal people. In a couple of industries that I'm familiar with, there are actually ongoing interest in how to detect insider threats from trusted parties inside your network. That's a lot of the reason why a lot of people are going to this concept of zero trust internal to their network.
Over there, I'm sorry. Yes, please.
I'm Paul Thomas with 3M, so Bill, you can't answer unless you answer last. My thought was, and especially when the comment about the Y2K thing, was that this discussion about protecting equipment, are we perhaps thinking of applying the same rules to all sorts of things? A lot of the software we use, I'll grant it, is we're sometimes running on Microsoft platforms. There's been examples given of like point of sale intrusion sort of things, which is a piece of software that's in many, many places. Whereas industrial equipment, if I write code for a machine, generally it's a one-off. So that's a very specific piece of software, granted maybe on a piece of industrial, off-the-shelf equipment, but the code is unique to that one. It's a specific chunk of code. And as a side comment, I think often is not given the value that it really has. You've got a little 2 megabyte file, and if you start thinking the amount of time it takes to generate that, debug it in people and equipment time, it's sometimes breathtaking. Are we thinking of I guess I would caution us maybe not to treat that the same way. Maybe it's something that could be treated entirely differently, just encrypt that pretty securely or severely so that you restrict access to it to specific points. We know where the data wants to go. It doesn't have to go everywhere like a web server does. So your thoughts on that?
Any thoughts?
So I'm presuming the code that you're referring to is what we're looking at now as technical debt. And if you are looking at small bites of code that have been running for 20 years, etc., when I started coding 30 years ago, my manager was telling me that I have to put notes in before every subroutine so that when another programmer looks at it, he can see what I've made up. That software is still available on the system today. And if you do something as simple as take it onto a Unix system and run the word strings, all the notes that I put in should have been taken away by the C compiler, and you'll find that they're still there. That technical debt really does need to be evaluated. Does that answer your question? Or?
He's just looking for comments.
Okay.
Unix, keep coming back to Unix machines or Windows platforms or that type of
That's not
operating
the issue.
system and that code, but there's a tremendous amount of industrial code that's not in that. It's in the programmable controllers that's running the production equipment. That's the stuff that's kind of at that level 1, level 2 area that, we want our machines to keep running, right? Keep making product, and we don't want people to come in and steal that intellectual property.
So would it be reasonable to say you're talking about a system integrity type of paradigm where you're actually making sure that the software is embedded and is protected, perhaps confidentiality, but also integrity? Is that kind of the paradigm that you're talking about from a deployed software standpoint? Right. Yes. I think many vendors are looking at that, especially with the idea of roots of trust at the lowest level and deploying that. A lot of the exciting trust mechanisms are coming out, like OPC, UA, that actually utilize a certificate authority and certificate for trust between nodes. I think this is something that really we should press forward in all speed, quite frankly, because the idea of having something subverted and not talking to us properly is probably a nightmare scenario in most people's case, and we want to prevent that.
You going to say something, Bill, or you don't have to?
I don't know if I'm allowed.
I was going to.
Go ahead.
No, I just wanted to add to that because I had a question I felt fit in very well with what you were just saying. I've had a lot of discussions with people. To me, a lot of the vulnerabilities that get discussed, and I think that you've been modeling, and nothing wrong with that, but that's just simply a chance to get into the system. But once you get into the system, into a control system, the issue is what do you do then? And if you look at the classic Stuxnet, I always hate to mention that, but when you look at that, you needed a group of engineers and physicists and everything else to know exactly what you wanted to do. So it was a lot of changes down there, which is now that, and so I want to make that point. The other point is we had a speaker in one of my sessions yesterday, and their view of cybersecurity was quite different. It's PAS, if you know PAS, but they're more on maintaining change, the managing the integrity or the asset inventory of and configurations of control equipment. And their argument, and I think there's validity to it, is the only thing that can cause damage in the end is when you get to the kind of equipment you're talking about, I think, in general. Plants are controlled with PLCs and DCS systems and controllers and things like that that are not Windows-based, they're probably not even Unix-based. So in order to actually do damage, some kind of damage to a plant, damage to the environment and all that, you have to, in the end, compromise those. Now, I'm not saying, if you might have an HMI and it goes down and it might disrupt things for a short time, but those are generally recoverable, safety systems. But it's when you get down and do the Stuxnet issue where you literally go in and change what's there and control differently and do all those kinds of things. So I think you were kind of talking about that. I mean, to me, so what my question is, I'm sorry, I'm talking without a question here. Though some others have, but that's okay. They're allowed, I'm not. Well, my question was more for the audience, but also the panel, certainly the panelists. Which of those are the big issues? I'm not trying to say neither of them are important, but how do we balance or how do you rate those things? Because, there's a lot of stuff in the world about software and finding vulnerabilities and protecting messages and safe communication, all that's wonderful. that's an issue. The other issue is that other aspect that I think he was talking about in essence. How do you protect, or how do you know that something has changed in the other? I'm just wondering your view on which is the real issue. Now, Bill, please.
Yeah, well, the most important issue is the one that happens to me. And, you know, that gets to, you know, what are we talking about, or what are we, obviously, we're talking about a lot of things today, and whether or not you're talking about where the system is penetrated to the point where they're trying to do damage or control my system, hide something, have me make bad product or whatever, or are we talking about where someone's going to come in, not really touch anything, but just extract out all the information that I have on my systems and then try to replicate it or learn from it or whatever else, sell it. Totally different things. Either way, you're going to be penetrated, and you know you're going to have to deal with it. So all of those things are important. I mean, and again, it's the one that happens or that's happening that becomes the most important at that point. But before that, it's all important. And you know, setting that mission statement or what you're going to protect and how you're going to protect it, I guess, you know, is deciding where you're going to put your resources, those limited resources we said. You know, we are being given money, we are doing things, but you know, which ones am I going to focus on? So I don't know. Talked around it. I almost see material.
Could I ask another question? I'm asking over there, but yeah, certainly the audience. I want to give that floor to you first.
Maybe this is new business, new territory, even for this conference. But do we feel that we're doing the right thing with respect to the criminal and international law and enforcement aspects of our response to this problem?
Anyone up here want to take that? Please. Gary, how about you?
He's not going to speak. All he's doing is just putting it there.
Yeah, no, I'm being very careful before I talk, but I think overall the answer is no. These types of things are so new, especially from the standpoint that many people that have poked at this start getting into international issues. But one of the things I think that is heartening is that there's beginning at the foreign policy level, with agreements between nations of what's acceptable behavior, and understandings by nations, what constitutes something going on. What I think is also important is that there's an ecosystem of these exploits being handed down to B teams, to C teams, to D teams, and sometimes those are criminal organizations. Ultimately, that may or may not have any connection with the nation state, may be loosely affiliated, may even use it for a hacktivism type of attack that's even more problematic. And I think that really that's where we have to get some international organizations and international understanding of what's acceptable and chase that type of stuff down, because that's a lot of people are leaving some of their tools on the floor, quite frankly, and they're getting picked up by people that may not be playing by the old rules or any of the rules that are currently being picked up.
As we've looked at some of the interactions between the different groups of actors who are involved, and knowing that you have actors who are working both to promote security and to undermine it, we need to be very careful about the sorts of legislation, the sorts of enforcement that we put together, because any enforcement that influences both of those groups together may have unintended consequences. And so I think we're going to have a very strong understanding of the human dynamics of those systems when we write that piece of legislation, so that we don't have worse outcomes than we're trying to achieve.
So are you referring to a chilling effect against a white hat community type idea?
In some ways, yeah. Essentially because the way of knowing about how to protect against these attacks often involves knowledge of how they are conducted. And that learning process is one of participation in some ways.
And knowledge, and they don't wear hats, so I just...
No, you're totally right, and we simplify it for the purposes of modeling.
Absolutely, but and also there is something, there's this whole gray area of like pulling people back to the light side. Sorry for the science fiction reference, but I think there is and that's one of the things that I liked about your talk, was the idea of there is a feedback loop, perhaps, of influencing bad actors to be, for the better good, to actually turn coat, so to speak. I think that that's something that really, from a public policy as well as an international policy standpoint, needs to be explored, because that's the reason why I brought up the idea of, do we really want to encourage? And I think I heard the resounding yes, so I hear and obey. But the idea is that the number of smart people working on your systems and looking at your code is directly proportional to the number of problems that will be found with it. So, it's good to start recruiting more smart people to our side, I think.
And going back to that, when the question was asked, do we really want to encourage hackers to be in our system? I'm poacher turned gamekeeper, and to be honest with you, my answer was no. And I shook when I saw how many people in here said yes. Yeah. Going back to an analogy that Sid said earlier on, so he was saying that some function had started using sensors. The biggest frustration for me from cybersecurity, and I don't come from an engineering background, is walking into the plants, into the control rooms. You have the best sensors in the world, but you've not switched them on. These guys have been using their DCS 15, 20, 30 years. They'll see something go wrong. It might be just something slow on the screen. It might be a flicker or a light. There should be a something's wrong button. But because they've come from an engineering mentality, they'll go behind and they'll flick about with the cable and they'll fix it. Because we've not educated them to understand what the threat is from external sources. And I believe that if we educate our people within the control room, they're the best sensors you'll ever get, because they understand the system better. And I've learned myself that they're the people that are teaching me where the weaknesses are, because they live and breathe that system.
Sure.
So that's where the value is in the people.
Any more
We have
questions?
time for maybe one more.
Thank you, and hopefully not too slow, the question. So what you just said reminded me, a couple years ago, there was a fire in downtown Boston by a electric transformer. It was in the basement of Hilton Hotel and shut down the power grids in Boston for a whole week. All these upscale restaurants, all their steaks and everything was thrown out, and it was devastating for Boston. And so our class was involved with the Boston Fire Department to investigate what happened, and the electric company was NSTAR. And we went to see their SCADA control center. And this is a very interesting thing. They have two things. One is the operator told us they see thousands of alarms coming through every day. And most time when we were there, they're just like a click off, click off, click off. So because there's so many, most of them are false alarm. So there's a lot of that going on in the control center, whether the operator is alarm fatigue, can they really detect a minor blip in the system? And the other interesting thing to me was in order to detect, there was a oil pressure leaking. That oil pressure hydraulics monitoring, it's a room as big as this, was in the other end of the room. And here's all the people monitoring alarms. So there's alarm going off, there's an oil pressure drop. So the two coming together would have signaled a real event. But because the design of the SCADA control system, it was so far apart and it was such a quiet room, everybody's quiet, staring at the computer, nobody's shouting at each other. There was no way to connect these two pieces of information and to say, oh yeah, conclusively there was something real going on in the system, and the alarm wasn't kicked off. So it brings back to a question I have, and it's for folks from industry here. This draws a big parallel with safety. When you identify a vulnerability, the cheapest and the most effective way to mitigate it is prevention through design. So in this case, it would have cost you nothing to identify you needed those two pieces of information to decide there's an event. And in your design of the SCADA or your communication, it would have cost you no money to bring these information together on the same screen in your design and be able to identify such an event. So that's the cheapest thing. There is nothing you have to put in to detect or additional detection or armor, and not saying any of those are not important. So prevention comes first, it's the cheapest, and detection, diagnostics, mitigation, and then bring it to a safe state, put on protective gears and operator training. So in that order, it gets more and more costly, and it gets less and less effective. So my question is, when we talk about cybersecurity cost money, we need a return on investment. How much effort in the industry or how much recognition do you have for prevention that maybe doesn't really cost you anything to begin with in the initial stage of the design? I don't know if there's any comment. I see some hands in the back.
There's Stephen Graham.
Thank you. My name's Stephen Graham, Dow Chemical, but retired like Eric. I would completely agree with that. There are methodologies in oil and gas process industries called hazard and operability studies. I think there's a chance to extend those, to talk about another, so you have more of, less of, some of, but another. Is my signal correct? Is it another place? That takes place way early in the design exercise. So you would trap that kind of thing. Second point would be, if you're going to assess what you guys are calling cybersecurity, which is a confluence of hardware designs, network designs, middleware software, the ability to go up and down the multiple layers of the enterprise and pass information appropriately, the engineering design stage has to include some IT guys, and there has to be some education going on. Otherwise, you're just not talking the same language. I've been blessed to work in manufacturing for 11 years with process control. I've done 25 years of SAP, and I've, I suppose, lived the dream. But the two guys, they kind of get to the river, and then they work out you're on the wrong side. I'd also like to talk a little bit about how I think you have two problems, and Bill Cotter said it. There's an intrusion problem, and I'm looking around for information. And then there's an intrusion problem where I'm going to try and do damage. And I come lower and lower in the systems to do that. So one issue is preventing intrusion. That's where you need your IT guys. From a process industry perspective, and the big guys, as somebody said, the installed asset base is the challenge. How much money can you spend on which piece, where, why? You have to do that based on risk. A chemical plant is, anywhere from $100 to $1 billion. And basically, it needs to be reliable, it needs to be available, it needs to be sustainable. Any problem that prevents that, whether malicious or not, is a problem. So you go through your designs and then mitigate the risk accordingly. But there is a ton of money that the big guys can use to influence. Because if they spend capital on new plants and their specifications demand the stuff that Jeff was talking about, hardened devices, hardened network, software validation, etc., if you don't support that, you don't get the business. You will eventually get to the point where cybersecurity gets built in. And you heard Peter Holicki in his thing saying he thinks it'll take 10 years. And he's probably right. The issue for the industries, I think oil, gas, chemicals, is what do we have to do in the meantime?
That's the issue.
Just, I want to say something real
One
quick.
comment to that.
Yeah, is that your question is very valid, and for anything that we're putting in from 6 months from now to, in the future, we ask those questions. How can we build it in? But we also have, and I don't know how far you should go back with computers, you want to say, but I've got 100 years of hardware still out in the field. What do I do with that? How do I look at that and approach that problem?
So I think that's a great place to stop. I really want to thank Sid for helping us out moderating both panels. Panel members, Gary, Jeff, Bill, of course our speakers, James and Michael. And also I really want to thank ARC for both the great conference and the vision to invite us here and combine us and include us in the program. And I really appreciate their hospitality for that, and I really like mixing these two. So let's have a round of applause for
everybody. Everybody for everybody.
Thank you. And thank you all for staying.